All right, we're back. We are GAME3001. That's Game AI at George Brown in the winter 2020 semester, and it's week one, part one of our broadcast. And today we're going to be talking about kind of a review of C++ object-oriented programming design, as well as the SDL template that I've created for you. So if you guys go up on Blackboard, there is under Labs, I'm not logged in, but let's just see if I can actually log in. I'll be okay. If you go up to Labs on the left, you can see that there is a SDL Template version 3 that we'll be talking about today. And if you download that, then and you run it, I'm running it in Visual Studio 2019, and I'm going to ask you to download and install 2019 as homework if you can. Now I know some people don't have a laptop, don't have access to a laptop, and that's fine. If I was going to run this in 2017, let me show you how that looks in order for you to run it. So when I run this thing, in order for you to test it, a couple things you have to do. One is in your Solution Explorer, when it decides to come up for me. Here it is. If you look at your Solution Explorer, I have to right-click on my solution and retarget my solution. That's the one thing you do, right? So please do that before you run your application. When you do, you're going to get something that looks like this. A window is going to be created, and you're going to get a little game.
Yay.
Right?
Yay.
Pretty simple. So that's the game you're going to make. That's like my hello world that I constantly make. I've made this game probably on every platform I can possibly do. So I've done it in Swift. I've done it on in Java with libgdx. I've done it with Python. I've done it with JavaScript and TypeScript. I've done it with Unity. I've done it with Unreal. Again, every framework you can think of. And why do you think I would make this game over and over again? Anyone have a reason why I would do this little thing? Why? Anybody? I know the game perfectly, exactly. So if I know the game perfectly, then guess what? I can learn the framework. I can learn the framework because I know the game. I've done this game a million times, right? Well, not a million, but a lot. Okay, but this is in 2019. What if I wanted to run this in 2017? Again, I'm moving to 2019, but you can still run it in 2017. And the way to do that is I would right-click on this, and let's say I open this with Visual Studio 2017. And in order for you to run this thing properly, you'd have to still retarget your solution and all that stuff. But you also have to change your build configuration. All right? So the place to change the build configuration is if you right-click on your project. This is in 2017. You're going to go to Properties, and then where it says Platform Toolset that says Not Installed, please change this Platform Toolset to a toolset that works with 2017, which is V141. Okay? If you change to Platform V141, then it'll run this code no problem. So please do that and then retarget your solution as before. Okay? That's what I recommend. So you just change this from V142, which is 2019, to V141, and then press OK. I'm not going to do that here because I'm going to run my project in 2019. So going back, here's 2019. You should be able to run your project now after you retarget your solution. And that's for everybody. All right, so a couple things you're going to note that you can also see is when I look at my solution, so if I go to Solution Explorer and I pin it up here, I'm going to start with main. And you can see that there's a lot of stuff in here that I'm doing. And it's probably a lot of things you're not used to doing, and it might make you even feel uncomfortable, right? Because a lot of files. I'm using this thing called Resharper Ultimate, and we'll talk about that. But let me take a look at main.cpp for now. So if you look at main.cpp, you can see that I have these other additional squiggly lines here that don't exist on your end. This is Resharper giving me suggestions on what to do differently. But what is Resharper? It's another tool set. And you can get it by going up to jetbrains.com/Resharper CPP. I'm going to take this link and make a new link up on Blackboard, which is what I recommend you get. So I'm going to make a new web link. And it's going to be this link. It's going to be an external resource. This is Resharper C++, which is what I recommend you download. Now, it's a proprietary tool that is not free. However, if you apply as a student, and there's a way, if you actually look at how to download this and use it as a student, there's a education version of JetBrains tools. I believe it's somewhere down below. JetBrains for Education. I forget where it is. If you look it up, you could find it. Actually, let's just do it together. So if I say, JetBrains Education, and it says for students, so it's actually jetbrains.com/student. You can apply as a student, right? You can click apply now and then fill in this form, and you can have JetBrains, the entire JetBrains library, which includes a bunch of really cool tools, not just Resharper C++, but also WebStorm and PHPStorm and even CLion, which is another C framework, C++ IDE. And there's also Writer, which works with, if I'm not wrong, Unity, right? So lots and lots of stuff that you can do here. With JetBrains tools. But the main thing that I'm using it for is for refactoring support, for C++. That's what it does. And one person asked me earlier today, what is refactoring? And it's code suggestions to make your code better. I'm of the school that I want my code to be quick. I want to get as much help from my IDE and my tools as possible to make my games as quickly as I can. All right, so that's what I want to do. That's why I use Resharper and other tools, other extensions to make it better. All right, so that is Resharper. So one thing you're going to note here in my code, this template is not like the templates you were given last semester. This template is an object-oriented template. That means that I use classes and objects here in C++. It's not perfect by any means, this template. And there's still lots of work we're going to do. This is the first iteration I'm going to show you, and we're going to build on this template as we go. So one thing to note is in the template itself, in main, so I'm looking at main.cpp, which is inside the source files filter. Remember that in Visual Studio, these things aren't really folders, they're filters. And they're looking at a particular, the operating system files are, they're placed somewhere. And for you to find out where the operating system, what does it look like on the operating system, if you right-click onto template, and if you go down to open folder in File Explorer, you'll see that it looks like this, and you don't see anything. There's no files. There's no CPP or .h files. But this template folder is the default folder if you were going to create new files, and that's not where I put them. I actually put them inside the SRC folder. This is where all your files live, and this is where I want you to put all your new files, inside the SRC folder in here, right? Now you wouldn't do it in the operating system. You're going to do it here in Visual Studio, but you want to make sure that Visual Studio knows where to put them, which it should be all in here to make it easier for you to code. Why easier to code? Because if you want to do includes, if you want to include your own files, they should be something that your Visual Studio project should find. I haven't included the template folder as an include kind of directory, so you must put them in the SRC folder for now. All right, so let's go through this. So we have main, and we have our frame rate that I'm setting to 60 frames per second. And then down below, you can see that there's a while loop. This is your game loop. And then you have this part right here, which frame limits. If I just have a while loop and I run my game is going to run as fast as my while loop can run, which is bad. I want to run my frames, each frame, 60 times per second. And so that's what this part here does. It delays your frame rate so it matches the frame, the delay. Notice that I've got this underscore here, this little green underscore. This is Resharper at work, telling me, hey, Tom, you could do this differently. If I click onto it to get code support and I go to my little light bulb, it says, hey, maybe you want to use a static cast instead of a old style C cast. Or maybe you want to use a functional style cast. Let me show you what this functional style cast looks like. It looks like this, and it actually changes your code to match it. So it gives you code hinting to make this better. And I like this. This is exactly the same as an old C style cast, but I'm using the C++ style right here. Okay? So I'm going to save this, and I'm going to have this as the new way of doing it. Also, it gives me some suggestions for frame time and frame start. It says, hey, declaration and assignment can be joined. I don't want that to happen. That doesn't make any sense for me because I want to declare them up here, and inside the while loop, I want this to be updated every frame, so I can't declare them and update them here because I would be declaring them more than once, right? So I don't want this to happen in here, and I definitely don't want this to happen up here because I want the assignment to happen every frame. Every frame, I want the new frame start time and end time, which is what's happening. Okay? You're also going to notice this pattern, the game, : instance, and then init. So this is something you probably have never seen before, right? And what this is me using something called a Singleton design pattern. So not only are we using, in this class, object-oriented design principles, but we're also using something called design patterns. So design patterns, there are 23 design patterns that were created by the Gang of 4 back in the day. So let me show this. So 23 design patterns, Gang of 4. And if I was to bring that up, you can see that they made a book called Design Patterns. Let's see if I can find it here. Here we go. Here's Wikipedia. Wikipedia has this book called Design Patterns. Again, it was made way back in 1994, in the 90s. These group of programmers, that's why they're called the Gang of 4, they came together and they said, look, we keep doing the same stuff over and over again, right? And we want to make best practices so that other programmers using object-oriented programming techniques can, kind of use these design patterns that we found very useful, right? So in your programming career, my recommendation is you understand how to use design patterns, right? And we're going to use several in this semester in our course. One of them is the Singleton design pattern. However, I want to also direct you to another book, which I find is very awesome, which is specific for us, which is called Game Programming Patterns. Game Programming Patterns is from this gentleman, Robert Nystrom. He has a website that he hosts that is the whole book. It's free for you to access. And if you go to the website, it's a really cool book because it's design patterns, but specifically for game programming. He's modified them so that it makes sense. I recommend this as a good read for you as game programmers, okay? If you read this book, it'll just make you a better programmer, I believe, right? At least better than what you were. And if I scroll down, you can see that there's a web access right here. You can also download the PDF, and you can also buy the book. If you want to support the author, please buy the book. Notice that there's a bunch of design patterns that he talks about here, and one of them is the Singleton design pattern. So you can see that that's the Singleton design pattern. He talks about how it works, and he also gives you some code samples about how this would look. I'm adhering, for the most part, to this design pattern here, and I'll explain it in a second. So this is the design pattern. Let me go back out there, and this gameprogrammingdesignpatterns.com, I'm going to copy this link. And again, on Blackboard, I'm going to include that in the lab's content area. So game programming, design patterns book. There you go. All right, so you have access to that too. You can please take a look at this because we're going to be using this semester from one degree to another. Okay? Yes, is that a question? No? Or are you just putting your hand up? All right. So yeah, so we're using game design patterns. Again, we're going to use the Singleton design pattern. And if you look at our code here, you can see that I've got something that looks like this. The game, and then instance, and then init. It's almost like I've got to go to the game class, go through the instance to get to my function. That's what it looks like to me. Okay? And let me explain this for a second. First of all, in our course this semester, because we're using object-oriented methodology, our C++ code is going to be divided into .h files and .cpp files. The .h files for our classes are the interfaces, right? They're going to describe the functions, and they're also going to describe the variables, and we're going to use these functions and variables inside the CPP file. Why are they separate? Because in C++, functions are not hoisted. What I mean by that is if you're programming in C# or Java, and I make a function, I create a function in C# or Java in a class, it doesn't matter where you use it in your class. Once you create it, it's available everywhere. Not so in C++. In C++, it's in creation order, right? But if you forward declare it in your interface, what ends up happening is you can use it in your CPP file anywhere you want. And that's one of the reasons why we're doing this. The other one is from a maintenance perspective, right? So if I look at game.h, which is where I'm going to look first, you can see that in my game.h I include several libraries. And sometimes I don't want to include the same libraries here as in other places. I may include different libraries on the CPP side, right? Maybe something that I don't want to reuse over and over again. So notice in my game I have these preprocessor commands. If not defined game, then define game. And we do this, so between line 3 and all the way to the bottom where we have line 86, this creates an area, a region, where if I've already defined the game, you know what? Please don't go here and redefine it again, okay? Don't define it again if I've already defined it. So what this means, because it's a preprocessor command, when the compiler goes through and takes my code and puts it together, right? I don't want to put my game together more than once. It's only going to see this header file one time, and it's going to stop any kind of conflicts this can possibly create. All right? So that's why I use these preprocessor commands up here. Other preprocessor commands that I use to link things together are the include commands. And I'm including different folders that I've stated inside of my build configuration. One thing I will not be doing this semester is really monkeying around with my build configuration too much. My build configuration, if I right click and go to properties of my project, can be found here. And you can see that I've already set up my build configuration to work within certain folders. If I go to general, you can see that I'm looking at a certain include folders here. And again, there are quite a few of them. I've included all of the SDL, the relevant SDL libraries here for today, and I'm going to add new ones in the days to come. So when I give you the next template, it's going to have everything you need to run SDL and to make your game successful. Okay? But I'm not going to change the build configuration. We're going to run with debug mode in x86 for most of the semester. If you want to make it run with release mode, you'd have to get those specific libraries to run, and you have to monkey around with the configuration, which I'm not going to do. Not for this project. All right, so that is main. And if you notice main, it calls game. And game is a class. And in the public area, so there's the public area of the class starting here, I have this static game instance function. Remember, this is the singleton, right? So how does the singleton work? There's different parts to it. One, if I scroll all the way down, if I go to line 68 of my singleton, you can see that I have a private area here. Line 57 says this area is private, and all variables and methods defined in here are private. They're only available to the class. Two things that I make private right away are the constructor and the destructor. This means that you cannot instantiate an object of type game ever. It's private. You can't instantiate stuff if the constructor is in the private section, right? It's not available outside the class. Furthermore, I create this static game instance. And notice it's a game pointer. It's a raw pointer. And it points to it. The way this has been named is like this. S for static, underscore for private, P for pointer, and then the name of the identifier, which is instance. So it's a static private pointer instance. That's what it is. And this is a kind of a naming convention that we use in C++, different places, and that people do things slightly differently. But this is what I'm going to be using this semester. So when you see S underscore P, it means static private pointer. That's what it means. Okay? So this static private pointer is a pointer to game, this class itself. And by default, question for you, is this initialized? Have I initialized this variable in any way? It's a yes or no question, guys. Is it initialized? No. If I have a pointer and it's not initialized, what does the pointer point to right now? No, it doesn't point to null. It points to a random memory location that I have no idea what it's looking at. It's like pointing at the sky right now, the bit bucket in the sky. You don't even know where it is, right? So we need to initialize this at some point. When I go up to the public area now, if and when I initialize this as a null pointer for the first time, it says this: my static game instance, this thing, which returns a pointer to the game, right? If my S underscore P, so static private pointer instance, if this is equal to null pointer, if this has never been initialized, right, but just null pointer, then I want to create a new instance of the game. Question, when I use the new keyword, what kind of memory am I allocating? Heap memory or stack memory? Which type? Heap. When I use the new keyword, I'm allocating memory on the heap, right? And what's the difference between stack memory and heap memory allocation? Does anyone know? So it's a lot of stuff I'm covering this class, so please pay attention. So when I do stack memory, right, it's usually good when I'm using a small scope. I create stuff, for example, inside of a for loop, a temporary variable. When that variable comes out of the scope, when the scope finishes, that variable lives and dies inside of that scope. That's a stack type allocation, right? Typically. However, if I use the new keyword, even in a scope, immediately I'm using something called the heap, which is a dynamic memory allocation method, right? I dynamically allocate memory on the heap. It's randomly allocated. And one of the advantages is I don't have to worry about something called stack overflow, right, which is where stack overflow comes from. However, the disadvantage of using heap memory is two things. One, this is a raw pointer. I have to manage it. I have to not only create the stack, the heap memory, but also delete it afterwards. That's number one. And the second disadvantage is you can get memory fragmentation, right? Because if I allocate stuff on the heap, for example, two variables of different sizes, and they're right next to each other, and then I delete one, and maybe, or let's say if I had a few of them, and I want to put something that's larger and there's no space, then there's a big hole inside your memory that's not being used. So you have these memory fragments all over the place. And this is bad. This is why game engines typically have something called a memory management system that allows you to manage your memory manually and allocate them in contiguous memory segments in the heap, right? We're not doing that here in this class because we're not building a game engine. We're just building a template for you guys to learn AI, okay? So here I'm actually allocating some heap memory, and I'm returning a pointer to the game instance that I've just created, right? This pointer to the game instance is stored here in this private static pointer, and then I return that back to the calling function, whatever that is, okay? And I do this once. If I come back to instance again, I check. I say, well, is my static private pointer instance null? Well, no, it's not going to be, which means I skip this whole code block and I just return the same instance that I've already created, which means I never create more than one. So why would I want to do this? Why would I want a singleton? Well, I'm never going to make more than one game. I'm never going to have more than one window. I'm never going to have more than one renderer. I'm not going to have more than one audio manager, collision manager, texture manager, font manager, whatever. There only ever is going to be one, right, of each of these things. These are good cases for singletons. So advantage of singleton is you only get one of them, and you don't mess around with, pointing to the wrong thing. Disadvantage of singleton is it's a global. Once I create it, it's in the global, scope forever, right? Which can be bad. Okay. So there's different options here. This is one option. Now the singleton is not quite done. Remember what I said. If I come down here, and this on line 68, if I'm pointing to a static private instance, this pointer, right now, until I initialize it, this is pointing at nothing. So in this case, this check here would fail because I don't know if it's null pointer. By the way, if you see up on your code, yours might say 0. 0 or null pointer are the same, and null pointer was a suggestion from Resharper, right? They said, hey, wait a minute, 0, you might as well use null pointer because that's the same thing. So how do I complete this? How do I initialize it? Well, if I go to my CPP file, so game.cpp here, you can see that on line 3 in this scope, in the CPP file, this is where I initialize my s_p instance to null pointer. And this is how I got to do it. I can't do it in the constructor because the constructor is never going to be called until it's too late. Right? I got to do it before, outside of the constructor. And I'm doing that here. Is that clear? Maybe not. Again, I highly recommend reading Robert Nystrom's book and taking a look at the singleton design pattern. He goes into detail about what a singleton is, how it works. He describes how the singleton pattern book describes it, and some pseudocode about how it's being used. All right? So please take a look at this whenever you get a chance. All right, so we make a singleton. It's only one. And then for the rest of the functions that we have in my game.cpp, notice that I have some lifecycle functions. That's what this is. These are lifecycle functions. I have a render function, an update function, a handle events function, and a clean function, and they get called from the main.cpp. So here's how main CPP calls them. The game instance, which creates a singleton for the first time, and that's usually done up here. And then whenever I access this again, I'm just accessing the same instance and calling different functions. Here in the while loop, which is really the main game loop, these are the lifecycle functions. Now, question for you guys. Why would I separate update from rendering? Why don't I just make it in the same function? Why did the book decide to do it this way? Because I'm using the book. The book I'm referencing is called SDL Game Development. So SDL Game Development. It's this book. Now, you don't have to buy this book. This book is also available up on Safari Books Online, right? As well as it's available in your Toronto Public Library, in other places. But it's a really good read. I think it's a good book. And it really details SDL2. And this is where I got the pattern to make this template, right? So I'm just going to copy this for the book. And just in case you wanted to buy it, I'm going to put that up on Blackboard as well. So if you're interested, here's the book. You can get it on Toronto Public Library. And I'm going to show you that link in a second too. So this is SDL Game Development book. That's the book I'm referencing. But if I was going to look this up on Toronto Public Library, so if I go to torontopubliclibrary.ca, and if I was to look up that book, SDL Game Development, and if I have a Toronto Public Library card, then you can see that I can access this book, right? Here it is. And it's the exact same book, access online. I can use my Toronto Public Library card, right, to access it. And then I get something that looks like this. Look, I have the entire book and the contents of the book right here. So there's no need to buy this book, and it's a great reference for you guys. So please use this book. Okay? But going back to this part, right? I have these 3 lifecycle functions, and I asked you a question. Why separate the update from the rendering? Anyone have a clue as to why I would do that? You guys are quiet today, and it's okay. I know there's a lot of stuff I'm telling you. So the update. A lot of times I can put this in the same function. However, there's some really good call for this. What if I wanted to pause the game? I maybe don't want to update anything while the game is paused, but I may want to draw everything continuously every frame until I unpause the game and then everything starts moving again, right? That's one reason it could be used. The other thing that I might want to do is maybe in a larger scope when I'm making this into a game engine, and not just here because I probably wouldn't use SDL to make a game engine, but maybe what I'd want to do is run the update and the render functions in different threads. I can use concurrency and multi-threading to create an application, my game engine, and I can run these 2 things in different threads to improve my performance and my optimization. Here, there's no need for that, but this framework allows you to do something like that. Some good reasons to do this. All right, so what do these functions do? So if I go back to the game.cpp, you can see that my update function, here's my render function. It draws all my game objects. Here's some game objects, ocean, island, and player. And there's also clouds. And then it updates each of these things. Player, island, and ocean, and then clouds. It does that, right? The game.cpp also wraps up my SDL functions. So if you notice in the .h file, it includes a couple of things, right? A couple of things it includes in the public area are an init function that sets my game running as true, m_b, private Boolean variable that's running. I set this to true, so my game is running by default, right? And then I create another, an overload of the init function that takes in the title of the game, the X position, Y position, width, height, and full screen, so that way it wraps up the SDL functions you guys talked about with Alex last semester. So if I go to the definition for this, go to definition, you can see that my init function does exactly that. I get my X and Y position, and then what I do is I SDL init my SDL init everything. And this is just an enumeration. That's what this thing does, right, or macro. And if you notice here, I've got this flags thing. And some people ask me, like, what's flags, Tom? Well, the reason why I'm even seeing this is because of Resharper C++. Resharper C++ is giving me some code hinting and saying, hey, this SDL init everything is satisfying my flags parameter for my SDL init function. An SDL init, of course, is an SDL function. It's part of the framework, yeah.
So then all the grid text, is that all from Resharper?
This part it is, yeah. All this and this and this and this and this. That's all Resharper. If you don't see these things, it's because this is from Resharper. It's actually giving me the variable names of what those things are. Okay? They don't affect my program in any way. All right, so I initialize everything. That's what I did. Maybe Alex would have just initialized the video. It depends what he did last semester. And then what I'm doing is I use this SDL create window function to create my window. And what's happening is I get a reference, a pointer. That's what this thing returns. If I hover over it, it says this returns an SDL window pointer. That's what it returns, right? This SDL create window is actually, if you think about it, a factory, right? Instead of me saying I want to have a new window, I don't use the new keyword to allocate memory. And of course, SDL and SDL2 is a C library, not a C++ library, right? What it's going to do is allocate memory on the back end and return a pointer, a raw pointer to that memory. That's what this thing does, okay? So if it does this, it returns a raw pointer, and we store this raw pointer in m_p window, which is a member variable that's private, that's a pointer. Right? I'm going over this over and over again so you guys get the naming convention if you don't have it already, right? So I'm storing it here, this window. And then after I have the window, I do the same thing with the renderer. I create the renderer and store a pointer reference to it inside m_p renderer, right? If everything goes well and there's no errors, then I'm going to create my game objects. And this is a function that I made. If I go to create game objects, let's go to definition. You can see here what I'm doing. I'm allocating memory on the heap for each of my game objects. And in this case, this cloud game object, I'm just pushing it onto a a vector of clouds. And I'll talk about that in a sec. But that's what I'm doing. I'm creating my game objects, and then in my update function and render function, my render draws everything, and my update updates everything in my game. That's what it does. So back to main.cpp, when I call my update and render functions in the while loop, every frame, my update is called in game, and my render is called in game, and the update and render in game call the update and draw functions in my game objects. And that happens every frame. Okay, that's how this thing works. But what the heck is my game object anyway? I mean, I have a bunch of game objects, but what are they, right? Well, if you look in your Solution Explorer again, and if you go to GameObject.h, again, what I talked about before is I'm using inheritance, right? I'm using object-oriented programming. And by the way, sometimes this can be bad. In a real-life game engine, maybe I wouldn't use inheritance. Inheritance actually is not that great from an optimization perspective. Let me explain why. Think about this. I have a game object. My game object is the parent of all other game objects. My parent is pretty small, right? But when I make children of my parent, they are fatter than the parent. In programming, in object-oriented programming, all children are fatter than the parent. Why is that? Because my parent has a memory footprint. I'm inheriting all the stuff that's in my parent, right? And then I'm adding specialization to my child. And so I'm actually increasing the amount of memory that my child requires, which means my child is physically fatter than my parent. The other thing that C++ allows, which is not like other languages, is multiple inheritance. Does anyone know why this can be bad? Why can multiple inheritance be bad? I can have a bunch of fat children, but I'm talking about multiple inheritance, like as in more than one parent. It allows me to have more than one parent in C++.
Wouldn't that mean that the child would be bigger?
If the child would be bigger, but never mind that, but I can have a conflict. What if I have a mommy class and a daddy class? I'm just putting it out there like this, right? So bear with me. I have two classes, a mommy class and a daddy class. And the child inherits from both those classes. What if those two classes have the same function name? Function A, as an example. Both have function A. Which function A does the child inherit? From the mother or the father? Which one? It doesn't know. By the way, there is no gender, of course, in classes. This is just progenitor classes, or the parent classes, two parent classes, right? So which function does it take? It doesn't know how. It's ambiguity. There's a lot of ambiguity around it and uncertainty, and it causes there to be a compile error. It wouldn't work, right? And this creates something called a deadly diamond, where we have two parent classes for one child that use the same function. And if you're not careful, it can cause a problem. Only C++ does this in modern languages today. Most modern languages like Java and C# do not allow multiple inheritance, right? Only crazy programmers like us, we're the ones that use it. Only the game programmers. The rest of the sane world, and that's 90% of the world out there, they don't use multiple inheritance, just us. Okay? Because when we program in C++, we're programming with the training wheels off. We have access to a plane that we're flying with C++. And there's lots of switches, right? And buttons and levers that we can pull. And if you want to crash the plane, it's totally up to you with C++. You can totally crash that plane, right? Not so much in C# or in Java. In C# and in Java, it'll guide you. It'll help you so that you have good memory management. Java and C#, as a good example, do automatic reference counting and garbage collection. But where C++ does none of that. C++, you have to manage everything on your own, right? Which makes it more challenging. However, from a performance perspective, C++ is much faster. And that's why we make games of C++ and not C# or Java, typically. Although games have been made with those languages as well. So here we notice that in my GameObject, I have this enum that's been set up. What this enum is it defines different GameObject types. Like it says, I have an island, a player, a cloud, and so on. Because I'm going to have different kinds of GameObjects. And the enum is just almost like a placeholder, if you will, for an integer value. Look at the value. Here's value 0. This is value 1, 2, and so on. And then I have this trick that I use, number of types. A number of types basically says if I want to know how many types I've defined, I can just go to number of types. Because notice it says number 6. The value is 6. Well, there's 6 types. 1, 2, 3, 4, 5, 6. Starting counting at 0, of course. Right? 6 types. That's how I can do. That's why I use this thing. So that's the GameObject type. And if you notice, here's my GameObject. I have public GameObject constructor and destructor. That's what I do. And then I have 3 lifecycle functions for each GameObject. But whoa, what the heck is this? I have virtual. Now, I want you to look at this for a second. And let me ask you this question. If I just had the virtual keyword in front of a function, what does that mean? Just virtual. Does anyone remember what that means from last semester? You guys should have seen this. Just the virtual keyword in front of a function. It means that the function may be overwritten. That's what it means. That means I could, my inheriting class, my child class, could have the exact same function name, but I could write a different implementation for that function. Okay? Now here's something different. What if I make it virtual, but I also make it equal to 0? If I can make it virtual equal to 0, this is something called a pure virtual function. And as soon as I declare one function in a class pure virtual, what happens to that class? That class transforms into something else. What does it become? Anybody? It becomes an abstract class. An abstract class, and again, those classes exist in C# and Java as well, cannot be instantiated. You cannot make a concrete object of an abstract class. That means I cannot use the new keyword, and I can't allocate memory to allocate a child of type or an instance of type GameObject. And it makes sense because there is no GameObject. I'm making a plane, I'm making an ocean, I'm making an island. I'm not making a GameObject. Ocean, island, and planes are GameObjects. They have an is-a relationship. It's an is-a GameObject type, right? But they are not the generic GameObject. This is too generic. It's like me making a person class. Person has no context. Sure, you're a person, but what type of person are you, right? Are you a student? Are you an international student? Give me more details. Specialize me a little bit, right? Because it's too broad, person. Right? Same thing with GameObject. It's too broad. We need more specificity. So we make a child class of the GameObject superclass. And it's an abstract superclass because we never are going to instantiate an object of type GameObject. However, I do want to compare one GameObject to the other. And that's why I make it abstract. So that way I can look at the plane and say, what's the plane? The plane is not just a plane. It's a GameObject. And so too is the island and the ocean and the cloud. They're all GameObjects, which means I can require or I can request a parameter of type GameObject. Because a plane is a GameObject, it fits that parameter list. But it's a specialized GameObject. It's a plane. And we'll see that later on. So if you don't know object-oriented programming, and what we're talking about here is abstract classes and objects, we're talking about polymorphism here, right? So one part of object-oriented programming is information hiding, private instance members, and public getters and setters to create properties from my object, right? That's one part of object-oriented programming. The other part is inheritance, creating an inheritance chain, a parent and a child class. And then we want polymorphism, the ability for me to have a method that I want to rewrite or override in my child classes, because I can have different forms of that method. That's what polymorphism means. It's Greek for many forms, right? So, knowing all these things, right, that this is a pure virtual function makes this an abstract class. Unfortunately, there is no abstract keyword in C++. We have to use this syntax to trigger this class as to make it into an abstract class. That means we can never instantiate this class. However, it also has regular functions here that we're accessing. We're using these getters and setters, right, to get and set values of these private instance members. Notice also that I'm using the GLM library here, right? I've included the GLM library for your use. GLM is a very popular library in the computer graphics world. It basically describes vector 2, vector 3, vector 4. A vector 2 would be x and y coordinates plus a bunch of other functions, right? A vector 3 is x, y, and z. What's a vector 4 for? Anybody have an idea? X, y, and z, and w. Yeah, x, y, z, and w. A vector 4 a lot of times is used for quaternion rotations in 3D space, right? And it's also used for RGBA, for color declarations, right? I have 4 values for color, right? Red, green, blue, and alpha, transparency. So 4 components, 4 floats, and that's a vec4, right? So we can have those things as well. So instead of me declaring my own vector classes, vector 2, vector 3, vector 4, plus a bunch of other math, I'm just using a built-in library or a library that exists out there that's very popular. I may elect to change this in the future. I may make my own little library because this library, GLM, is quite large, right? But we'll see how it goes later, depending on the time. So I have a bunch of private instance variables, that's what they are, and they're just regular variables of type vec2 or integer or string, whatever they are. And what I'm using is my getters and setters are functions that access these private instance variables, which is, again, adhering to object-oriented design principles, right? That's what I'm doing. Yay, the GameObject superclass, which is a monolithic class, right? Now, in real life, if I was going to make a game engine, I wouldn't use a monolithic class because, like I said before, it makes all child objects fat. What I'd rather use is something called an entity component system, an ECS. That is a better way of doing it. If you look up entity component system, right, it talks about what this thing is, right? An entity component system basically creates, I want to see if there's maybe an image for this that I can show you quickly. Yeah, it's a crazy thing like this, right? Where basically what you have is a bunch of entities and a bunch of components. So a good example of this is I have a transform component. For example, not every game object needs to be rendered. I don't have to draw every game object. What if I have a placeholder like, for example, a spawn point? A spawn point can be a game object, right? I have a position, an x and y value that I want to keep track of. But it's not going to be rendered. It's going to be invisible. So therefore, if I use my monolithic game object, guess what? It could be rendered. I have extra code that I'm never going to use. It's a waste. And we don't want to waste anything, right? How about this? What if I use my big game object to make particles? I have these little particles, and I have 10,000 of them, and each one of them has all of these properties. It's too much. It's going to be really computationally expensive and inefficient to make use of my game object for particles. It doesn't make any sense, right? So I could use something called an entity component system. Why am I not using an entity component system here? I'm not making a game engine with you guys. Number one, it's going to take too long. It'll take months to make something good, right? 2, it's more complex than the stuff I'm giving you. Way more complex, right? And this is already complex for you, right? So I don't want to do that. And there's a lot of knowledge that needs to go into an entity component system as well. It's a totally different architecture. Unity, which is a very popular engine, is using a new entity component system with their DOTS framework, where they use data-oriented design. All right, so we've got this game object, this monolithic parent, right? And I want to inherit from it with my player. Let's take a look at my player.h. So player.h is another class, again. And can anyone read line 9 for me and tell me what this says in C++ language? Can anyone attempt that? Anyone's willing to try? Read line 9 for me. What does it say? Guys, you guys are not reading stuff for me. Okay. Megan, do it. Read line 9. You're the one that's been answering. Go. Just read it.
Class player public game object.
Well, what's happening in between public game object? What's that colon? What does that mean?
Oh,
Semaine, what does it mean? Inherits from, or you could say, I like this word better, extends, because it makes the child fatter, right? It extends the game object. The parent game object, right? It extends it. So that's what I read it like this. My class player extends the public game object and makes it fatter, right? That's what I think in my mind, right? And it makes it more specific. It's more specialized. My player class is a more specialized version of my game object. That's what it is, right? And I have 3 little functions that I override. These functions are the same function, the same lifecycle functions I described in my GameObject.h. Look, the same functions. But here, I must override these. I must override these in order for me to adhere to, the superclass, right? So when I look at my player.cpp, let's take a look at that really quickly. So here's player.cpp down here in the source files filter, right? You can see that in my player.cpp, I have these 3 little functions. My draw, what it does is it calls the texture manager. Oh man, what the heck is this? Texture manager instance. What is that again? We see another thing like this, a texture manager instance. What is that? What does that pattern look like to you? We just described it with the game. What is it? It's another singleton. There's the singleton again. And if you actually go there, if I right click and go to definition, you can see that yet again, we have another singleton that looks almost exactly the same. Here we're using 0 and not null pointer, but our refactor, which is Resharper, if I just click on here and I go to the light bulb, it tells me, why don't just replace the expression with null pointer, which is what it's suggesting. That's why the power of Resharper is. It helps me do things better. It makes recommendations, right, for me. And actually made some recommendations for player that I ignored. Here's some recommendations for the player draw function. Take a look. It says, wait, you should probably use the override specifier when you're overriding a function. You don't have to, but you probably should. And I like that idea. I'm going to do that for each one of these things. You can see now that I'm updating my code, and it's not going to matter anything. It's not going to change anything here. I'm still going to be able to run this thing, and it's going to be okay. The only difference is this is more explicit in terms of how it's going to run. Okay? So that's what the power of Resharper is, right? Yeah, it's good. It's really good. Good for performance and good for understanding. It's also good for style. So if you're someone who's going to be the lead programmer, who's the lead programmer here? Anyone? Do I have lead programmers here for groups? Anybody? If you're the lead programmer, guess what you're going to have to do? You're going to have to establish a style guide for your whole team so that everyone codes in a similar way. Otherwise, you give me your code and it's some weird thing and I'm going to go, what the heck is this? Right? Here's what we don't want to do this semester. I don't want to see X's and Y's or I's and J's or U's and V's unless you're describing something with them. X's and Y's for locations, U's and V's for a UV map. You know, they must make sense. Make sure that your variable names are contextual. All right? That's why I'm using longer variable names. Yes? Yes, because it's just, like, although you can make it index if you really want to. But yeah, you can totally use I and J for for loops, no problem. That's the simple use. Does that make sense? So this is what Resharper allows me to do. Notice there's some other things that Resharper is suggesting. It says the destructor type hides a non-virtual function from class GameObject. And it might give me a suggestion of what to do. It says make base destructor GameObject virtual. If I was to do this, it's going to make my GameObject pure virtual, right? Which might have some other effects. I'm not going to do that right now. It shouldn't do anything negative, but I'm not going to do this one. You can elect not to use the recommendation it gives you. However, I have to tell you that for the most part, they're pretty good. So going back to my texture manager, what is my texture manager? Well, it looks pretty good, guys, right? It looks like another Singleton. And I have several functions that I'm defining here. One of them is the load function. What the load function does, if I go to definition in my texture manager, is it allows me to load a file name, assign a friendly name for the texture. Remember the texture, what it is just a bitmap. We just call it a texture in game programming, right? And the bitmap is data. And I want to store this data for the image somewhere so I can access it later. Instead of me always, loading from the operating system, I want to load from the operating system once. And I want to reuse that texture over and over again, right, for different objects. For example, let's suppose I have 50 enemies that use the exact same texture. Do I want to load from the operating system 50 times? No. I want to load from the operating system once, right, and store that texture, and I can reference it as a pointer in my code, right? So I'm loading it. Here's the file name. I make a friendly name for it. I need a reference to the SDL renderer because it's going to be contextual. This texture is going to be relating to the surface that I'm going to be drawing it into. Once I have the texture, I use image.load, which is an SDL image. It returns an SDL surface, and I got to convert it from an SDL surface into a texture by using this create texture from surface function, right? Now I have a texture, and I want to store it inside something called a texture map. And if I look at what this is, if I go to my texture map, you can see that inside of my texture manager.h, I'm defining a standard map in the STL, standard template library. I'm using a standard map, and maps have two parts, a key and a value. Key value pairs. This key is a string, and the value is an SDL texture pointer, right? That's what it is. So then, when I use the load function, it stores my texture with my friendly name that I gave it, which is the ID, inside of this texture map. And I take a reference of the texture pointer and store it inside the texture map. So whenever I access the texture map, right, I get the pointer that I stored there by using the name. For example, if I use the name player, as opposed to using an index like 0, 1, 2, 3. We don't use 0, 1, 2, 3 as an example in a texture map or in a map. We use whatever the key is. In this case, I'm using a string for the key. So I'm going to use player, cloud, island, ocean. And that's going to return, when I say I want the player, it's going to return a pointer to the player image. That's what's going to happen. Okay? That's a texture map. I also have a draw function, and if you see that the draw function itself, I use the ID of the image I want to draw. It retrieves the image from the texture map. That's what it does. And it draws it. It basically creates a rect, an SDL rect, as a source rect, and an SDL rect as a destination rect. And basically it copies the texture from the source to the destination and copies it onto the renderer. And you should see that this function right here is something you might have used last semester, almost exactly, right? But instead of it being out in the wild, I'm doing it here inside of a texture manager where I can access it and encapsulate it nicely. Okay, that's all I'm doing. All right, and there's several iterations of the draw function that I have here. There's also something called draw frame, which allows me to do animation. Okay, frame-based animation. I also have a couple of utility functions I've defined. One of them is get texture size, which uses SDL query texture to take a look at the actual texture itself and return the width and the height. Okay? And I also have this function called set alpha, which allows me to set the alpha transparency of the texture if I want to make it somewhat transparent, which I did with the clouds. Okay? So that is your texture manager. And if you notice, it's right here. If I keep going back, it's being used right here in my player draw function. My player draw function calls the Singleton instance, and it draws the player. This is the ID from the texture map. Here's the player. And basically what it does is it gets the X and Y position of the player where it exists. I use a reference of the game's renderer, right? And I also specify that my texture is centered. This means that the pivot point of my texture is not the top left corner, but rather the exact center of the texture, right? And this is key. I don't always do this. I do it for the player, but not for the ocean. The ocean is going to be the top left corner, okay, for the pivot point. All right, so now that I've done this in the draw function, and then I call the update, and what this update does is it basically gets the mouse position from the game and assigns the player, right, whatever the X position of the mouse is, so too is where the player moves. And if I was to run this thing, you can see that happening. You can see that when I move the player's plane, it moves wherever the mouse pointer is. My mouse pointer, my plane follows the mouse pointer exactly, right? And that's this because I'm getting the mouse vector right here, right? Meanwhile, the get position on the Y value doesn't change because I'm not actually changing the Y value. My plane is locked at 430 pixels. Why 430 pixels? I've done this game, my Hello World game, just a few times. And so I know where I can put it, right? However, smart thing to do would be to not code it hard like this, hard code it, but put it somewhere in a config file where I can change it later, all right? And it would change everywhere in my code. All right, so this is my player. Similarly, I have other game objects. Let's go over them. One of them is my ocean. Let me take a look at my ocean for a second. My ocean is a little different than my player. And if you look at my ocean, it follows the same pattern, but this is what the ocean does. Take a look. Scrolls forever. How is this happening? How is it scrolling forever? Is that? I'm repeating my texture. I'm not loading it again. I've got this massive texture. It's 1440 pixels high, right, by 480 pixels wide. So basically it's 3 screens high. That's what it is, right? And it starts, the top of the texture starts off screen. And what happens is when the top of the texture gets to the top of the screen, it resets. And it keeps doing that over and over again. It keeps resetting. It looks like it's an endless scrolling ocean, but actually it's just a texture that keeps resetting over and over again, right? Now let's see if you can spot the reset point. Did you see it? There it is. There it is. There it is. So what's actually happening is it's not a perfect tiled texture, right? And a better way to do this, if I had more time, I would have 2 oceans. I would have one ocean and then another ocean underneath it. And then when I reset, I would reset off screen, not on screen like it's showing right now, right? I would have my oceans positioned in a different pattern, and my oceans, as they moved off screen, so let's say this ocean moved down, right? This ocean here would reset off screen. So you would never see the line that separates the 2 oceans. You could also have a seamless texture if you can find one, right? That makes sense, or make one for yourself, right? And you guys are going to make games potentially that are scrolling. You can scroll right and left in the same way, right? You're going to have a texture, and instead of you making it endless, you're just going to make a texture and then reset, right? You're going to just reset the texture over and over again. And you're just going to keep moving it back to where it was before, off screen, until it scrolls into view, inside of your viewport. That's what's going to happen, right? If that makes sense. So that is your ocean, right? And what's happening is you can see that I'm using the draw, update, and clean functions like I described before. But I also have 3 more functions, a move, a check bounds, and a reset. Let's take a look at those. So go to definition. Here's my move function. My move function says, well, first of all, I set inside of my constructor, I set the velocity of my ocean on the y-axis to 5 pixels per frame. That's what this is. That means it's moving down the screen 5 pixels every frame. If I'm updating at 60 frames per second, how many pixels does it move down every second? 300 pixels is the answer, right? It's moving 5 pixels every frame. There's 60 frames per second. So 5 times 60 is 300, right? I'm moving 300 pixels down the screen every frame, or every second. That's the speed. And then what happens is, in my update, I call the move function and the check bounds function. My move function adds the velocity to the position, and then we set that new position every frame. And then in my check bounds function, it says, hey, if my position on the y-axis is greater than or equal to 0, that means it's more than the top of the screen, it's hit the top of the screen, well, then reset. We want to reset it back to where it was. And my reset function moves it back to a negative 960. Now remember, this negative 960 is hard-coded. And maybe what I want to do in future is put it somewhere in a config file so it's not hard-coded like this. What if I replace my ocean texture with something differently sized? Then I would want to change this number or calculate it somehow. So that is my ocean. So my ocean keeps scrolling continuously, and I'm reusing my asset over and over again. I'm not instantiating new oceans every single time. Remember that instantiation causes memory fragmentation and computational increase, right? More computations per second. And what does is it changes my performance from my game, right? I take a bit of a performance hit every time I instantiate something. So the general rule is, don't instantiate anything during gameplay. Instantiate everything ahead of time. Okay, let's go over this in a second. And I'm going to show you this in a couple of more examples. Here's another example. I've got my island.h. My island.h is exactly like kind of like my ocean. I have my move, check bounds, and reset, right? And if I want to find something different, let's take a look at my reset function from my island. So if I go to definition for my island, you can see that my reset function is slightly different. Let's see how different it is. Well, what's happening here is my X component, that means the horizontal position every time it resets, is going to change randomly. I'm going to get a random X position every time my island resets to the top of the screen. Some random position across the X-axis to make it look like it's a different island, but actually it's the same island, right? So I'm resetting my island. And this is okay. What about my cloud, though? And by the way, my island, just before I move to the cloud, the island actually also moves at a velocity of 5. You want the island and the ocean to kind of move at the same speed because then it looks kind of weird, right? The island isn't like a boat. It doesn't move faster than the ocean. It's on top of the ocean. So it has to move at the same speed. But not so with the cloud. If you take a look at the cloud is a little different. So here's my cloud.cpp. If you look at the cloud.cpp now, right, you can see that, well, I don't define a velocity here at all for the cloud. I actually define it in the reset function. My velocity for the cloud is going to have 2 components, my x-axis component and the y-axis. In other words, my cloud has the capability of drifting randomly to the right or to the left. It also goes down the stream faster or slower. So I can have some fast clouds and I can have some slow clouds. I can have clouds that drift and whatever. And I can do even more things in this. I can make the clouds, if I really wanted to, rotate. I can make them different sizes. I can do whatever I want to make it seem as if they're different clouds. But guys, they're the exact same cloud. They're just different instances of the same cloud. So this is cool. But what about in my game.cpp? How does this work in the update function? How do I update all my objects? Remember, in my game.cpp, I have and by the way, if you want to look at this, see, this is game in Visual Studio. You can look at this game context, and then I can just literally pull down where I want to look. I want to look at my create game object. I can just zoom right there in my Visual Studio, and you can see that I create my island, my ocean, and my plane, and my clouds. But my cloud is created in this for loop, right? Because I have more than one cloud, right? I create my clouds and I store them inside of a cloud vector. Now, one person asked me this morning, they said, why a cloud vector? Why not a cloud array, right? Yes, a cloud vector is more heavy duty than a cloud array, for sure, right? However, it's dynamically allocated, right? So what if I wanted to add 5 clouds in the future, or 10 clouds in the future, or something else, right? In a array, I'd have to pre-allocate that number. I'd have to say 10, 5, whatever. In my vector, I'm not pre-allocating. I'm just dynamically allocating how much memory I need in my vector as I go. And I'm using a for loop to do that. I'm building up my cloud vector in a for loop, all right? Now, there's going to be some issues with this, right? So sure, I create game objects, but I have to update each of these clouds. And notice there are anonymous cloud pointers that I'm adding into my cloud array. And my cloud array, my vector, if I go to definition, you can see that it's a vector of type cloud pointer. That's what it is. A vector of type cloud pointer, which means the vector only holds pointers. It doesn't hold the entire object in memory, right? It points to them. Again, using raw pointers. Guys, be careful with this, right? So when I push back, I add an anonymous cloud pointer onto my cloud array. So when I want to update, let's go to the update function really quickly. Here's my update. When I update, I say, okay, here's my island, my player, my ocean, and then what about my cloud? Well, I got to use this structure here. Megan, how do I read this thing? You're a good reader. How do I read line 113? How do I do that? What does it say to you? It's a for loop, but it's a different type. What do I do here? How do I read it? Yeah, so it's like, you read it like this. Good try. But it looks like this. For each cloud pointer in my clouds vector, for every cloud pointer, or for each cloud in clouds, for every one of them, do this. Update that cloud and check the collisions for between the player and the cloud. Check the collision between the player and the island. That's what I'm doing, this check collision. I'm going to go back to collision check in a second. But I'm using this special for each loop, or arranged for loop is what it's called in C++, which you should have learned last semester. Okay? So I'm not using the standard for loop. Okay, here. So this is good. So this is my update function. And what about my render function? Well, my render function works kind of the same. Here's my render. I'm clearing the screen. I'm drawing everything. I'm drawing each of the clouds. And then I render present. So I clear it and then present it. I redraw everything to the screen. Okay? But let me go back to that update for a second. What the heck? What is this collision check thing we're talking about? And wait, there is no instance here. What is the collision? Because I'm using a different pattern here. I'm not using a singleton. There is no instance. So tell me, what do you see this is? What is this? This is the collision class. What is this? It's not a singleton. So what type is this? Can somebody else answer other than Megan today? Because she's the only one that's been answering for the most part. Anybody? Take a crack at this? Take a chance. Maybe you'll be wrong. It's okay. You'll learn. All right, you fearful people. It is a static class container. That's what it is. And now I'm going to ask you another question, a follow-up question. Why not do this all the time? Why even use a singleton? Why not just use static classes like this? Look, I have a static squared radius check function, right? And my collision manager constructor and my destructor are private, like singleton. But I don't have that whole singleton instance thing. I don't have an M instance anymore. I don't have that. So why not just do this every time? What's the disadvantage? Well, the answer is that in a static class, we'd have to make all of our variables static as well. And static classes are in the global space again. Everything. That means not just the class itself, but also the squared distance as well as the squared radius check. The only thing that this class is doing is acting kind of like a namespace. It's saying, okay, I want to make a little container that has a bunch of static functions, but it presents other issues later on. If it was a larger implementation than this, it'd be really unwieldy. It'd be hard to maintain, right? But in this case, I wanted to show you another option. You don't always have to use singletons. You can also use static classes like this, if it makes sense to you. Let's take a look at our squared radius check and see how we do collision detection anyway. So you can see that my squared radius check takes in two objects, object 1 and object 2. But guess what? They're game objects. I'm not looking for specific game objects. I'm not saying plane and island here. I'm saying, hey, look at these two game objects. I don't know what they are, but they're two game objects. Because isn't a plane a game object? Yes, it is. It has a relationship with GameObject. That's why I inherited from the GameObject super abstract class, right? And same thing with island. Island is a game object. It has an is a relationship, right? So because they're both game objects, I can check to see, I can declare their positions as P1 and P2, right? And I can do a squared distance check. Squared distance check says, okay, what's the distance between the centers of the two objects? The center of object 1 and the center of object 2. What's the distance in pixels? Now square that. Okay, cool. Whatever the distance is squared, give me a number. I'm just going to give a number. Let's say 100, right? And if that distance is less than the squares of the radii, so the circles, right? That means we have an overlapping circle, which means we must have a collision. And this is another way of doing collision detection. You guys did AABB style collision detection last semester. Axis aligned bounding box, right? Here, we're not using boxes, we're using circles. That's what's happening here, okay? So once I detect that there is a collision, I say, okay, there is a collision. I check to see if object 2 is colliding. Is it already colliding? If it's already colliding, then don't do this. Yeah, I only want to do this stuff when it's not colliding. Because remember, if I make it so that it's always going to collide, guess what's going to happen? Let me take this check away. Let me just take this check away completely. And notice what happens right now. Right now, when I run the code, right? No problem, right? But if I took this check away, if I took this check away, so let's just comment this out. Bear with me while I do it. I'm going to comment this out, and I'm going to comment the bottom up, right? So it's constantly colliding. And if I did that, if I did this, right? It doesn't matter. How about just like, let's make this true. If true, here, this is always going to run, right? If true, then, hey, make a collision. Let's see what that happens when I do this. If I did this, look what happens now, right? If I didn't check it. Right? Do you hear that? It's doing this. Yay. It's colliding every time. It's every motion that it's doing through the plane, through the cloud, and through the island. It's colliding every single frame, right? I don't want that to happen. I only want it to collide once. In order for me to do that, I need to put that check into place, which says, hey, if it's not already colliding, then collide. If it's already colliding, don't do this anymore. We only want to collide once every time. Okay? And then what I'm doing is I use this switch case statement, and I say this. I say, okay, fine, cool. If I'm colliding with island, that's the type. Remember I did that enumeration for the type? I say, if my plane is colliding with an island, then make a yay sound. If my plane is colliding with a cloud, then make a thunder sound. And one thing I'm missing in this whole code is, what if I had a scoreboard manager where I showed the score, I could maybe subtract score when I hit a cloud, and or subtract lives, and maybe add score when I hit an island. I could do that, right? So this is another thing we can do here. I've also made it so that I can have bullets hit me or enemies. I've just kind of put these in place. They're just placeholders. And so you can have collision detection of different kinds. So guys, this is the framework that you're going to be working with this semester. This is the base. I'm going to expand upon it. Every lab we get together, I'm going to change. I'm going to give you version 4, version 5, version 6. I'm going to keep giving you different versions that have more functionality as we go forward. Why am I doing this? Because I want you to start off with a base like this so you understand the code. Because it's going to be your job this semester to produce assignments with this code. You're not going to be allowed to use Alex's code from last semester or your own code. You're going to use this code as a base. I'm going to say use template version 5, use template version 10, whatever it's going to be as we go forward. We haven't described any AI this semester so far, just my template. But let me recap what we talked about today. We reviewed C++ object-oriented programming. We reviewed raw pointers and how they're used. We introduced a couple of different design patterns. By the way, there is another design pattern. I talked about Singleton, but the other design pattern that I'm using, which is what I talked about earlier, is in the game.cpp in the update function, right? Or, I'm sorry, not in the update function. Yeah, in the update function. See this? I'm using a cloud pool. So I'm using something like object pooling. Object pooling is an optimization pattern, right? Because I don't want to use new clouds every frame, every time I reset. I want to use the same cloud. So I pre-allocate my memory with clouds, and then I reuse them, right? So imagine instead of clouds, I have bullets. I have 1,000 bullets. I have a bullet hell shooter. So instead of instantiating new bullets every frame or whatever, when I'm kicking a bullet out, right? I pre-allocate all my bullets, put them inside of a bullet pool, and then call them into being when I need them, right? They're pre-allocated. Why? I don't have to access the operating system, file system. I don't have to get new textures for them. I'm not going to have more memory fragmentation and computational decrease, right? I don't have to do any of that stuff. It's more optimal, right? Optional. So that's the object pooling. And again, if you want to look at that, if you look up online for object pooling, and if you look at that book, remember this is the Singleton design pattern, and we can also go back here and we can scroll down from an optimization perspective. There's object pool. An object pool, what it does is it allows us to reuse objects as opposed to create new ones, if that makes sense. Okay? My guys want to play D&D this week. Again. Questions around this framework that I've given you. It's kind of a template more than a framework. Again, guys, lots of stuff we covered today, and I've got reports from Monday's class as well as this class this morning, and they said, yeah, that's a lot. I got a lot today, Tom. It is a lot. But remember, we can't continue using non-object-oriented code. We have to move on. And for AI, like I said in lecture today, AI is a tough class. It's tough because you're learning advanced C++ techniques, or more advanced techniques, not quite fully advanced. There's still more things we could do to make this even better and crazier, right? But more stuff. We're using design patterns, and you need to know how to do object-oriented stuff, right? So the assumptions that I asked you about earlier today are, I'm going to assume that you know object-oriented programming. And I know some of you are not quite 100% comfortable with OOP. I know it because you just learned it last semester at a very low level, right? So this semester we're going to start practicing that. Okay, so next week, homework for you guys. Visual Studio 2019. If you have access to your own laptop, please install it. Make sure it's ready. Try and make your own game object. Get a little enemy plane, right? This is just practice for you. There's no marks associated with this. Get your own little enemy plane And let's see if you can make it bounce around the top of the screen underneath the clouds. All right, try and figure that out. How do I do that? I want to make a new game object. Remember that all of my code, right, if I look at my solution, right, all of my code, if I right click and go to open folder in File Explorer, it's not going to go here. You don't want your code going here inside template. You want your code going inside SRC, this SRC folder. If I was going to try and add a new class, take a look what happens. If I add a new header file, and if I right click and I add new item, right? Look what happens. Look where it goes. It goes to the wrong place, man. It goes to template. I don't want that. It needs to go to SRC. This is the first hint. I need to select this folder for it to go to. Otherwise, you won't be able to include the classes we made already, which was GameObject. All right? So, and try not to add this C++ class. If you do this, it doesn't matter what you put down here. It'll still go to template. If you add in the .h and the .cpp files separately inside your SRC files, that's a good start. So you need a couple things. You need some kind of image for your enemy. By the way, this challenge we're going to do next week as an in-class lab, right? So you needed some kind of image for your enemy, right? You need to do that. And you need a class, a .h file, and you need a .cpp file. You have to include it inside of your game.h, just like I did here. Look at the patterns I've given you, right? In your game.h, I include player, island, ocean, and cloud. You need to include enemy, whatever that is, right? And then inside of my create game objects, right? My create game objects function, this one. So I'm going to go to definition for this one. Create your object, whatever the enemy is. You have to create it. And then in your update, right? In your render, you need to draw it. And in your update, you need to update it. If you don't do these things, right, you can't create your own game object. There's some steps involved. Why am I getting you to do this? Because for AI, we need to create game objects. We need to create our own constructs. You need to have your own assignments that you make stuff, and you need to start now. So please, for homework, please do this if you have a chance. If you don't, I will give you the same challenge in lab format. You'll have actual criteria that you'll have for next week. It'll come up where you have to make your own game object. It's going to be worth 2% of your final grade. All right? I'm just letting you know ahead of time. All right, so please get her done. Questions around this template, SDL, C++, object-oriented programming, raw pointers. I keep going, right? Lots of stuff, right? Guys, thank you so much, and I'll see you next week. Next week's labs are on Monday, and I'll see you guys as early as Thursday, because you guys are my Thursday lecture class. All right, thanks so much. I'm going to stop recording now. All right.